Hi, I'm David. So I'm a SRE at Prezi, and I'm going to talk about how we introduced Prometheus. So I was the project lead during that project. So what's Prezi? We are an online platform where you can basically create and browse presentations like this one. In terms of scale, now we have over 100 million users registered, and behind that, 15 engineering teams, around 100 backend microservices. Most of them are in Python and Django, some in Scala, and very few in Go. And we also have web, desktop, and mobile clients, and we need to monitor all of this. So monitoring. The issue is like Prezi was founded in 2009, and guess what happens if you build 10 years of organic build-up, and also if you have a huge lack of best practices, what happens then? Well, you end up with this huge monitoring monster that we used to have. It was very slow and stable. We used to have to fix it often. So we had a lot of issues with this, but let me just walk you through how it used to look like. So I'm going to walk you through the architecture. Let's say you have a microservice, and if it misbehaves, you want to get a page. In our case, we use PagerDuty mostly, and also Slack. So let's go through how it used to look like. So the service didn't have any notion of metric. There was only logs. So debug logs, these logs will go then to a log processing node, and that log processing node, every 60 seconds, it used to process the last minute of logs. Actually, we had a custom Python script for every one of our backend services, a different Python script, and that would parse these logs and output metrics from them. And then these metrics would end up into a graphite, which is a time series database. And then, now that you have metrics, then you can query them if you want to evaluate alerts. So for that, we had what we call a checker node, which would every 60 seconds evaluate rules against our graphite. And then from that, you have an alerting state. And now you can say, okay, I have my alerting state. I can just send that to PagerDuty or Slack. Actually, it's not that simple. So every 60 seconds, actually, that checker node would send the state of every alert as logs to another node, which was called this multiplexer node, which would then convert this alert state as logs back as a metric into another graphite. Why a different one? Good question. But I said it's a multiplexer, so it was doing a second thing. It was also sending, finally, the alert state to an Itzinga, which is an Nagios fork, if you don't know. And finally, yeah, Itzinga can actually send that to PagerDuty or Slack. There was one good element. We actually use Grafana. So, which is good because our engineers knew how to use that. In terms of single points of failure, there is not a single one. There is multiple ones. So if any of these fail, our whole alerting pipeline and monitoring pipeline doesn't work. And it used to be done a lot. So compared to Prometheus, the standard architecture, I guess, now everyone is familiar with that. Prometheus grabs the service, alerts go to Alert Manager, they duplicate, send that to PagerDuty and Slack. We also have Grafana. We have multiple of these stacks. We run this in HA, 2 Prometheus per stack, and we have a single Alert Manager cluster. So that's it for the bad technical part, but there was also a huge lack of best practices, and especially a lack of common best practices because 15 engineering teams, 100 microservices, everyone used to do their own sauce, basically, and that's very bad. No dashboarding guideline, no alerting guideline. That means we had a service without any dashboard, actually, services with too many dashboards, dashboards that don't work, alerts which are bad, flaky, really bad things everywhere. So now we actually identified all of our issues with our 10 years of monitoring monster. So how did we actually sell the project? So how do you sell Prometheus? So first, what was really important is setting clear goals. If you remember this huge monitoring monster there, we split our issues into 3 main groups. First one, alerting quality. If you have alert fatigue, and actually we had this, we had outages due to people ignoring alerts. They didn't know, okay, is that an important alert or not? They were just on their way home, okay, maybe it's not important. And due to that, we actually had outages. So this we want to fix. Second one, user experience. Our dashboards were slow. So let's say you get a page, you go to Grafana, it takes like 1 or 2 minutes to load. Then if you want to browse, that takes time. If you make a change, you cannot know if it's effective or not. That also makes your outages longer. We also wanted to fix that. And finally, uniformity and future-proofing. So our monitoring system was not built for the future, and we actually want to move towards Kubernetes. now, and if we want to do this, we just have to revamp the whole thing. And also uniformity, as I said, we want the same best practices across the whole company and have actually monitoring as a platform. The second useful thing is to have a champion. In that case, that's you, or that was me. I was actually here 2 years ago. I was sitting there on that corner. And so if you have someone with experience, someone with a vision that can actually bring this forward and convince people, okay, that's the way that we should do things, that's really useful. A second thing is also running experiments. So for us, we had the chance of changing our CI platform 2 years ago. And we said, okay, for this new CI platform, let's just monitor it with Prometheus. And from that, we could actually learn and avoid making the same mistakes when we roll it out to the whole company. And we could also just evaluate whether it was a good solution or not for us. And finally, if you have this theoretical and practical experience, now you can scope and plan. And we came up with a great plan of all these things that we needed to do to achieve our vision. And now that you have a plan and that you have goals, you need to know, okay, how is your plan performing against your goals? So here I'm going to take the example of the alerting quality that we wanted to improve. So first, we need to identify key metrics. The first one is going to be the total number of pages, because for equal availability or a better availability, if you have less pages, well, that's better, because people wake up less often. The second one is acknowledgement rate. So if you are familiar with PageX system, usually you click acknowledge when you get a page. And if you acknowledge an alert, that means two things. One, the alert was not ignored or escalated, which is good. And second, it was not auto-resolved in a short manner. Because sometimes you get a page, you wake up, you pick up your phone, you're going to click acknowledge, but actually it's already green because it was auto-resolved because maybe you had a spike or something in your metric, and that's also bad. You don't want to get woken up for no reason. And finally, actionable rate. And by this, we mean having real and actionable alerts where you need a human being to go there. Because the third case is you get a page, you can actually acknowledge it, but there is nothing you can do. Maybe it was actually some other team which did something bad. It was not your domain knowledge. And so in this case, it's bad. So we want to fix these three key metrics. The only issue here is that if we use PageUtility, for example, we can get this total number of pages, and we can get this acknowledgement rate pretty easily. That's just stats. But the actionable rate, how do you get that? Well, actually, you need instrumentation. You need to ask people, was it actionable or not for every page that you get? And so for us, we did that through a Slack bot, which we call QualiBot. And so if you got a page, the next day, QualiBot will ping you and will ask you, okay, was this page actionable, non-actionable, or was it a duplicate? And from that, we can finally have our actionable rate. And now we can measure, and we actually have a full-fledged dashboard with all of our alerting quality metrics. So this is not Grafana, this is like product metrics. And in there, we can, for example, aggregate by team or by platform. So we can say, okay, this team has better alerts than the other team, or the Prometheus platform that we built overall provides better alerts than the previous one. And that's how you measure performance. So now, what did we actually do during this project? So here's a timeline. So we started last September to actually, from scratch. And we plan to finish this end of March. Turns out we needed a few more months, so we extended that for one more quarter. And since end of June, we are in maintenance mode, which means we just provide support for this new platform and fix critical bugs. So what did we do for during this 8 or 9 months? Well, there was the implementation of the new platform, so the technical things, and also the education of our engineering teams, these best practices that I talk about that we needed to spread around. So for the implementation, the main thing that we did was configuration generation. A lot of people do the same. We quickly identified that for people to write Prometheus config or Alert Manager config themselves, that's too much to ask, and that's also pretty complex. And also it goes against our uniformity goal. Because if you want to set boundaries, if you want to have best practices, that's just not going to pass. So here you can see the example of configuration for monitoring for one of our services, here which is called folder service. Here, for example, you can see the scraping config being set just by one line. If you set this line, it means that we will generate the scraping configuration for the Django exporter that we built. You can also set a group of alerts. So we have group of alerts here because, for example, for the security alerts, that's pretty useful because if you then add a new alert to that group, every service using that group of alerts will have this new alert. And you can also include alerts one by one and override thresholds if you need. So we provide alerting templates So we don't let people really write their own alerts. We provide templates for them, and they can override some thresholds if they want. And we also have target management for Ad Manager. So people can set up their Slack hooks or PagerDuty integrations just by writing code here. They don't have to do anything through the UI. The second thing was generic dashboards. So we saw that some people here have dashboard generation through code, like Graph-on-It and these kind of things. So we went another way, which is actually not having many dashboards, just a few dashboards, but they are all generic. So across our 100 of microservices, whether they are Django, Scala, or Go services, we use recording rules and best practices around labels. So we end up with generic metrics that are the same across all of our services. And then we can just have like 5, 6 dashboards, for example, that are all generic, where you can use Grafana variables. And then you have already your dashboard, so you don't have to build anything, it's already there. And third thing that we built is actually migration tooling. So if you have 100 services or more, and you need to update all of them to make them export metrics, if you don't have any tooling around making this faster, that's just going to take too much time. And if we didn't build this, we would still be doing migrations right now. There were also things slowing us down, main one being Django and Python, especially Unicorn. So if you messed around the multi-processes mode with the Python client for Prometheus, that can get pretty tedious. We actually fixed a bug there, so we spent some time there. Second thing is client-side monitoring. As I said, we have desktop, mobile clients, web clients. Prometheus cannot scrape this, so you need to have logs, you need to have log processing. And still, it's something that we don't feel like we solved the right way. I don't know if there is an actual right way. So if anyone has tips around this, especially something that would read logs from Kafka and export metrics, come to me, I'm interested. And finally, retention and scaling. So fine-tuning the parameters of your Prometheus. How much CPU, how much memory, how much disk, how much IOPS. Like, this took us some time to get a stable Prometheus stack. And even if you look on the internet, there is no best practices. You have to fine-tune it depending on your own usage. You have to iterate. That takes time. On the education side, we mostly base ourselves on these documents, My Philosophy on Alerting. I think it's an excerpt from the SRE book. So basically, it's a collection of best practices around alerting and monitoring. We also had a lot of presentations and sessions to educate our engineers. These are the best practices. This is how you use our new monitoring platform. We also provide continuous support, so people can come to us, to the SRE team at any point. They ask us, okay, how do I write an alert? How should I write this alert? How should I monitor this? It's very important that we are here for them and that we can continue providing these best practices. And of course, extensive documentation. I know this can be difficult, but that's really useful because if you provide support, it's really nice to have documentation to point to, so it's just faster for you. On the education side, there were also things slowing us down, mostly attachment to old alerts. So if you have an alert which is 10 years old, chances are the person that wrote this alert, in our case it was even in Chef, that was defined, this person is not there anymore. And now another person is in charge of that alert. And this person will not know, okay, is it okay to remove this? Is it okay to rewrite this? How should I rewrite it in Prometheus? And this creates a lot of debates, a lot of arguments across the organization. And so that can take time, and you have to be prepared for this. But the biggest point was lack of awareness. And by this, I mean, I don't know if you know Plato's allegory of the cave, but basically people didn't realize that there is a better world out there. So people were used to this like 8, 9 years old monitoring stack that was slow, that had 1 minute points of resolution, that had 2 or 3 minutes of delay, that when you are on call, it means that you get woken up every night. People were like, okay, that's how it is. That's how the world looks like. So there were like our engineering teams at the bottom of the cave. And we had to tell them, yeah, no, there is a better world out there. We can do much, much better. We can have like 5 seconds resolution if we want. We can have real time. We can have smooth on-call rotations. And we had to convince people that it's possible and it's doable. And so finally, how did we fare against all of these goals? So for user experience and uniformity, the simple setup and configuration was really appreciated. Before, as I said, so we defined stuff in Chef, and it used to take us like 2 or 3 days for one person just to set up monitoring, alerting, dashboards, if they create a new service. Now, if they create a new service, they don't have anything to do, it's already there. Just add a few lines of alerts if you want, and that's it. Generic dashboards are really helping us with that. We feel that that's a good solution. And finally, we also have monitoring as a platform. And by this, I mean that not everyone is managing their own monitoring. They just manage configuration for the platform that we provide. And that's a completely different thing. Because now, if we want, we can provide features to the monitoring platform. For example, in these generic dashboards, recently we could add annotations on Grafana for deployments. And we just did it. And now it's there for everyone at zero cost. And before, everyone would have to update their dashboard. They would have to add annotations. So it would have been a mess. And now it's a platform. We own this. And that's really helping. And real-time dashboards and alerts. So now we use actually 5 seconds resolution, and we have 2 months of retention. And so that means that, for example, if you're in an outage situation, before when you made a change, you would have to just make your change and then wait in front of your Grafana 1 minute, 2 minutes, 3 minutes, and maybe you see a point changing. Then maybe you wait for 2 points so you can get a trend. And that's already 5 minutes of outage right there. Now we have 5-second resolution. So if you make a change, 10 seconds later, you already know if it was effective or not. And just from that, you'd already save like 5 minutes of outage. And that's really important. And this was true actually only for 95% of our use cases. Because these are actually the happy use cases. If it fits in our platform, it fits in the configuration generation we built, but there is an issue because there is a remaining 5%, which is whatever is custom. So for example, we have a data engineering team, they use Kafka, they need to have monitoring for Kafka. If you need to do anything custom, which is not in the framework we built, which is not in the alerting template we built, then now you have to learn, okay, what is Prometheus? How do I write Prometheus configuration? What is alert manager? What's a gauge? What's a counter? How do I write from query? So now you have to learn all of that if you need to do anything custom. And that's actually more complex than what we had before. So that's the trade-off that we did. So for 95% of the use cases, you don't have to know anything about Prometheus. You just write a few lines and that's it. But for the remaining 5%, now you have way more to learn. So you have to make trade-off there. In terms of alerting quality, so for OnCall Experience, if you remember our key metrics there, we actually cut our total number of pages in half. Our acknowledgement rate was multiplied by 2, and our actionable rate was also multiplied by 2. So not only we have less pages, but they are better quality. So what key takeaways can we get from this? So migrating, and especially cleaning up, is a lot of effort. So there is a long tail to this, especially if you have 10 years of alerts to get rid of. Actually, we are still not 100% done, or Itzinga is still alive with a few things in there. Hopefully in a few months we can finally kill it. But yeah, you have to be prepared for that. Education is also a constant effort. So the statistics I just showed you before about better pages, and this was actually a snapshot from 3 months ago, because if you look at them now, actually our alerting quality stats are getting worse, because we feel that we didn't follow up on our education effort. If you don't have this constant education effort of pushing for best practices, of looking at what kind of alerting configuration people are creating, well, your alerting quality will go down. So this is a constant effort. You always have to maintain this alerting quality, otherwise it will get worse. Setting the project was an important part of it. We spent a lot of time on this. That's why I spent so much time explaining how you can do this. But in the end, we feel like it was a great success. Everyone is happy in our organization about this. That was really nice. As a bonus, we could also contribute to open source. We made contribution to the Python client for Prometheus. We also contributed to MTail, 1 character in the README. And also now we finally have easier and also safer Kubernetes migrations. And this is actually what we are working on right now. And if you are interested, we are hiring. Thank you.
Thank you. Here is your spoon.
Thank you.
So I can see one of those. So, questions? Where's the box?
It's in the cupboard in this charging station.
Don't normally get to say this, but who wants a box?
The companion team.
It's not weighted.
Great talk, thank you. How, in terms of, besides education, is your company thinking of like best practices for how do you basically make or try to prevent that in 10 years you don't end up replacing the one monster with another? It's not it's a great thing, but it's just the nature of this ecosystems, you know, it's like, sorry.
Yeah, so actually for that, even on the technical side, we made some choices. For example, I said we have 2 months retention. For example, we don't use any long-term storage solution because actually I feared that we would end up in this situation. So what if 1 year ago we said, okay, Thanos looks nice, we put Thanos there. Actually, I felt like, no, if we put Thanos there, maybe in 10 years it's gonna look worse. But doesn't matter, I mean, I'm saying Thanos, but can be Cortex, can be whatever here. So we tried to keep it simple. We said Prometheus looks pretty simple, looks like everyone is moving towards this. Same for Alert Manager. So basically on the technical side, we keep it as simple as we can, and that's it. And even long-term storage, even now we are not ready. Even yesterday I saw that people are still fighting around what's the actual solution to move towards. And so for the technical side, we just keep it as simple as possible.
Next question.
Thank you. Hi. Talking about this 5% of custom script alerts and so on, what do you have in there? Because we also had to migrate a lot of custom scripts alerts, so that's maybe interesting.
Yeah, so I would say the bigger part of this is actually cron jobs. So we built, we put a push gateway there, but even push gateway is not a solution we really like because that's also a single point of failure. And yeah, so these cron jobs, they have to run somewhere, so you have to find where to run them. And then what kind of metric they should output, or to put alerts in there. This can get quite complex. And sometimes, for example, a legacy cron job could be like rewritten now with like an exporter if you like rethink about the whole way of it working. Maybe now a cron job is not the best idea, but having a smart exporter would be nice. And so cron jobs are the biggest one, and also whatever is third party. So I said we have 100 microservices, Python, Scala, Go. These are easy because we control the code. Whatever is a third party application, we don't control the code. Kafka is one example. We also have other applications like this. So that's mostly around our data teams, security teams, which are in these third party things.
Hi. You mentioned a very high resolution on your metrics. What's the scrape rate you are going? The scrape rate. How often are you scraping the targets?
So we scrape every 5 seconds, and we have everything on a 5-second resolution.
Next question. Go.
You said you provided migration tooling to the developers, right? So that's one of the things we have is not all of our applications emits metrics into stats-D, so Graphite. How do you do that? Because that's our biggest part is actually getting them to provide a metrics endpoint that spits out Prometheus metrics.
So actually, when I said migration tooling, it was actually meant for us because we identified quickly that actually if we let people migrate, it's not going to work. So we did our migration in a way that we actually did it for them. So we actually migrated all the services by ourselves. So the SRE team actually made the move. Otherwise, it would have been impossible. If you start to rely on others to do this, it's just going to take forever. And so you have to be smart there and make it in a way that you can do it yourself. It can take time. You will have to collaborate, of course, with them. But I think the most efficient way is if you do it yourself. Sorry.
Hi. When you have different teams with different services, they have different needs. How do you treat the uniformity in the dashboard, services, alerts for different applications that have different kind of necessities in this regard?
Okay, so most of our services are actually just REST APIs, but in terms of generic dashboards, we support HTTP APIs. We also have one for workers, so Celery workers with a queue, so something that executes tasks. We can have also one for databases, but actually we are in AWS, so database monitoring is mostly done through RDS or CloudWatch. So we still have a few things there. But yeah, if we just cover HTTP APIs and service workers, then we already cover 98% of our use cases. Same goes for cron jobs with the push gateway, and that's about it. So I don't know if you have a specific idea in mind other than API or worker. But, yeah.
I was talking about different, I mean, services with custom metrics that have business metrics that they are very different in different services, because one is oriented to requests, the other to transactions, or different kind of service that have completely different business logic.
Okay, so we also let people write custom metrics and custom alerts if they need to, and that's actually the 5% I was talking about. So yeah, people sometimes define custom metrics. Actually, it's a very rare case. And in our documentation about custom metrics, we have like 3 big disclaimers that maybe you don't need this, be careful. Most of the time, everything is actually uniform and you don't need custom metrics. But yeah, so it's possible, but yeah, if you need a custom metric, you need to learn how to name it, how to use labels, how to name your labels. You need to learn a ton of things. So we try to limit as much as possible, but yeah, sometimes it's inevitable, and that's the 5% I was talking about.
Hi, great talk. Which team is responsible for Prometheus? Your team or the team which is using
the
it?
SRE team is owning all of this.
Okay.
We have time for more questions. Anyone? Put your hand up. It's like primary school. No one? Oh, there's one.
Hi, great presentation. I'm not sure if I missed some of the information. How many metrics or time series are you analyzing every 5 seconds?
I don't have exact number, but if you come to me, I can show you after.
Okay.
It's in the hundreds of thousands, I think, or millions, but not tens of millions. So I would say millions.
Millions.
I guess.
You never have problems with generating the alarms where there is a delay, in the sense that you need to analyze 1 million time series to then generate.
So we use recording rules extensively, and so mostly alerts are based on the recorded rules. In terms of delay, we don't really have too much delay. We also split our monitoring in multiple stacks. So we have 3 main Prometheus stacks, and so this is like divided between services as to not overload one. Oh yeah. So if you want exact numbers, I can show you.
Okay, I will talk to you then afterwards. Thanks.
Okay. Any other questions? Okay. Well, thank you very much.